There are two types of risk measures. One is absolute and the other is relative. Absolute risk is the risk of having an event like developing an illness or a disease over a certain length of time. For example, in the table, absolute risk in an exposed group is the number of people who experience the event, which is a disease, divided by the total number of people with and without the disease. Similarly, absolute risk in an unexposed group is the number of people who develop the disease divided by the total number of people with and without the disease. Everyone in life has absolute risks of developing different types of diseases, for example, risks of cancer, strokes, diabetes, etc. Absolute risk can also be defined as a probability of something happening, but it doesn't guarantee that it will happen. Also, an individual is not compared with another entity and is free from other criteria. Relative risk, on the other hand, is a comparison of the risk in two different groups, like comparing exposed group against the unexposed group. A common example is the possibility of developing heart-related events among those who are exposed to smoking versus those that do not smoke. Medical research is always keen to investigate if fitting to a particular group increases or decreases the likelihood of developing risk of specific diseases. For example, research studies have analyzed that smokers have a greater risk of developing cardiovascular ailments relative compared to non-smokers. Other examples are obese versus non-obese, low blood pressure versus high blood pressure, and so on. Now consider a cohort of investigating the risk of ischemic heart diseases taken in 12 months period with 500 patients who are chronic smokers controlled against 500 patients who do not smoke at all. Given the proportion of smokers in general population is 30%, the results are described as below. Relative risk will be absolute risk in smokers divided by absolute risk in non-smokers. It is important to understand the difference between the two risks. Absolute risk is the risk difference or excess risk in an exposed minus unexposed. Relative risk is when exposed and unexposed are compared against each other. Absolute risk could be attributable risk, attributable fraction, population attributable risk, and population attributable fraction. Relative risk could be odds ratio, risk ratio, or rate ratio. If you want to quantify disease burden in exposed group attributable to certain exposure, or to provide answer to questions like what the excess risk is due to or attributed to exposure, then it is calculated as risk or rate difference between the two groups. So attributable risk will be risk in exposed minus risks in unexposed. Attributable risk is the excess or extra risk difference between the exposed and the unexposed group. Attributable fraction, on the other hand, tells us how much by controlling the exposure would reduce the proportion of the disease. It may sound confusing, but you'll get better idea when we solve some examples. In this example, attributable risk is absolute risk in smokers minus absolute risk in non-smokers. The proportion of smokers is 4 in 1000 and non-smoker is 2 in 1000. Taking the difference would mean the incidence of ischemic heart diseases that is attributable to smoking is 2 in 1000. Attributable fraction is attributable risk divided by absolute risk in smokers. Attributable fraction is a very useful tool for epidemiologists. It says that if patient smoking exposure is controlled, we would expect a 50% reduction in ischemic heart diseases. Population attributable risk and population attributable fraction. When we involve the entire population, then to calculate the excess risk in total population, which is attributable to exposure, we need to know the proportion of exposure. In this scenario, if the proportion of smoking in general population is 30%, then population attributable risk is attributable risk times the proportion of smoking in general population, which is 30%. Therefore, the risk of ischemic heart disease in the total population that is attributable to smoking is 6 in 10,000. Population attributable fraction is population attributable risk divided by incidence in exposed times proportion of smoking in general population plus incidence in non-exposed, and it is timed by 1 minus proportion of smoking in general population. According to these results, controlling smoking in population would reduce the overall risk of ischemic heart diseases by 23%. Understanding of both these measures is important as these are a very useful tool for epidemiologists.